So yesterday's recording got recorded without the voice. So all the effort got waste. Anyways, you guys were there. Those who are not showing up, it is for those. So others will not come, I think, probably, right?
I don't know.
Yeah, I know. How would you know? Okay, never mind. So there was. So I'm recording this as an extra lecture because I didn't want it to carry yesterday's thing to Wednesday and then you forget everything. All of you were there yesterday?
Yes.
Okay. So, if you recall, we started this part 3. Constraint optimization. We first talked about the introduction where we gave the standard form. We told you what inequality constraint, what is a regular point, and we told you how to convert. We talked about active and inactive constraints in the inequality and converting inequality to equality. Then we talked about classification. Classification, first thing was we defined what is a local minimizer, right? Then we came to an LP, linear program, and we told how to convert from any given form to the standard form, which is the questions which you will do today on linear programming, the tutorial which we will do more. So then we focus more. Then we also talked about non-linear, where we did QP and CP. Okay. Then we started with transformation. So when we did transformation, we were focusing on two things. Okay, more of you are coming. Oh, I took out the wrong sheet. So what did we do in transformation? बताओ, कल ही तो किया था आदित्य.
Constraint to unconstrained problem.
Right. So we converted the constraint, but can you do a general constraint to an unconstrained problem? So we said when you have a non-linear, so we only worried about equality constraints. So when you had non-linear equality constraints, that you cannot always convert. You have to see the problem and do it. But what you can do is, when you have linear equality constraints, how to convert this into the unconstrained problem. So we gave you that you're trying to minimize f of x subject to ax equal to b. I'll come to the last, and then what we did was we did examples. So we did one example, and the second example we were trying to finish. So I'm going to revisit this today a little bit and revisit this today so that we can complete this section and then move on to necessary and sufficient condition. And this was A belonging to R cross N. R is less than N. Rank A is R. So it's a full rank, full row rank or full rank matrix. So what did we do in this case? What did we do? Kshitij? No. Ritvik? What's your name? Ritvik. Yeah, Ritvik, tell me. I still remember some names from yesterday. What did we do? So this is a general optimization problem with equality constraints. We are trying to convert this into, this would have infinite solutions. I told you the case of overdetermined, no solution, fully determined, unique solution or infinite solution depending of A being invertible or not invertible, and underdetermined, the case of infinite solution. Correct? So now what did we do in this case? We said let x be equal to A transpose Y, we said A transpose Y is equal to B, Y is equal to A transpose inverse times B, assuming this is invertible. X is A transpose inverse B. This was called as the pseudo inverse. This is one solution. So this is one solution because you're transforming the problem. Plus, to take care of infinite solution, we had A pseudo inverse A times phi. Is there an inverse there? No, that's it. Yes, everybody with me? We got transformed this equation to this form and we got one solution, and for take care of infinite solution we added this. The reason I am revisiting this is I had proven yesterday that if A is full rank, which in this case it is, then A transpose is invertible. Yes? How did we prove this yesterday? Shaurya? Or Atharv? Atharv? No. Atharv. Yes, Atharv. How did we prove this yesterday? We use the condition that if a matrix is invertible, A times X is equal to 0 implies X is equal to 0. That is the only solution, right? So what we did was, we started with, so what we have to show here is, show if A transpose X is equal to 0, then X is equal to 0. This is what we had to show. Everybody with me? We want to show that this is invertible. This is a square matrix, R cross R. This times X is, this is one of the characterization of an invertible matrix, correct? But what did we show yesterday? Tell me. We showed if A transpose X is equal to 0, then X is equal to 0. This we did yesterday. Everybody with me? How did we do it? We wrote A as A1 transpose till AR transpose, the rows, and then we said A transpose X is A1 through AR. These these were rows, they become column, times X1 to XR equal to 0, and then we said X1 A1 till XR AR equal to 0. Since A is full rank, the rows of these are linearly independent, which means these vectors are linearly independent. If sum of linearly independent vectors is equal to 0, the constants have to be 0. So this had implied that x1 is equal to x2 till xr is equal to 0 or x is equal to 0. So we had shown this part, but we had to show this. Everybody with me? The reason I am revisiting, I thought some of you might think and ask me. So tell me now, how should I prove the first part? Because I have proven a part of it, but not the main thing. I didn't have to show that this is invertible. This anyways will not be invertible because it's a rectangular matrix. It's R cross N. A transpose is N cross R. So we're not talking about invertibility of this here. We're talking about the square matrix here. So there was something which was missing here. How did I went from this to this? How should I go? Tell me. Are you getting the problem? That we had to show A transpose X equal to 0, then X is equal to 0. Instead, we just showed that A transpose X is equal to 0, then X is equal to 0. How do I go to this step when you have shown this? Sorry? Well, not exactly, because look, it's good that we're using this time. So we have shown if A transpose X is equal to 0, then X is equal to 0. This is what we showed. Now if I multiply with this A transpose X is equal to 0, then we have no idea what will happen to X. Correct? Because this matrix is changed. Earlier it was this. Now if you start with this and try to prove it, it will not be proved. Are you getting, everybody? Yes or no? So there was a missing step here which I am going to highlight today. Okay, so we'll start from this step and come to this step, and then rest of it you know. Is everybody with me? Okay, so we'll do is, we have to show, I'll keep carrying this show word with me. Show if AA transpose X is equal to 0, then X is equal to 0. So our starting point is this. Okay. So what I did was, I'll say AA transpose X is equal to 0 is given to me. Everybody with me? इतना क्लियर है कि ये है. अब I'll multiply this with X transpose AA transpose X is equal to 0. This changes anything? I multiplied both sides with X transpose. Changes anything? No. What I will do, I'll write this as A transpose X transpose times A transpose X equal to 0. This is all given. Is this okay? When you do transpose, the elements swap. So it will be X transpose A, X transpose A transpose X. So these are same terms. Everybody with me? What is the 2 norm of a vector? Let's say I have a vector M, let's say. This can be written as M transpose M. Yes or no? So what can this convert to? Given norm of A transpose X, which is a vector square, is equal to 0. Yes or no? It's just transpose of this times this. This is a vector, an R cross 1 vector. When is a norm of a vector 0? What is the 2 norm? It's sum of square of each element. Now you're squaring it. So if it was M, it will be M1 square plus M2 square till Mn square equal to 0. Means all M1 to Mr have to be 0. Which means that this vector has to be 0. So this is given. Yes or no? So now my problem transforms to show if A transpose X is equal to 0, then X is equal to 0. Make sense? Everybody clear? It had to be done in 2 steps. I had not shown you the first step. I thought you would ask, you go home and read. Nobody did anything. But is it clear now to everybody what we are doing? These kind of transformations and chote proofs, these are not too deep. So these kind of things you should get comfortable in this class. Huh? Everybody with me? Should we move on?
Sir, like what we did previously is when we said that if A transpose X equal to 0, then X has to be 0.
This is what we showed here.
Now,
but we had to show this.
So we can, like, we found a solution to A.
We found a solution to this equation. But what I am saying is, if you found a solution of this equation, how do you know that it is a solution of this equation? That's what Shaurya asked earlier, no? Let me erase this.
There will be additional solutions as well. Like it can happen.
Correct. I mean, I don't know. Look, what we showed was solve A transpose X is equal to 0, and we got that X is equal to 0. But this does not imply that if I solve for A transpose X is equal to 0, I don't know what X will I get. I have to solve for this guy.
But X equal to 0 will all, like, satisfy this.
That's okay.
Not the only.
But that it should be the only solution. That's what invertibility stays. Invertibility definition says that if a matrix times a vector is equal to 0, the only solution it has is x is equal to 0. So we had to find that. Of course, x equal to 0 will be, because both sides will become 0.
Sir,
Yeah.
A is full row rank.
Yes.
So A transpose should be
Full column rank. That's what
Full
we
column.
used here. It was full row rank. We converted it to A transpose. It became a full column rank. These vectors became linearly independent, and that is how we took it back.
linear independence is also applicable in full column.
Linear independence is depending on which vectors you're talking about. So if it is full row rank, then I'm saying that the rows are linearly independent. If I'm talking about full column rank, then the columns are linearly independent. Here we converted the row matrix into a column matrix. So rows became column, they were already linearly independent, they stayed linearly independent. Yes.
And we also try something like keeping A transpose x equal to y. Then if Ay equal to 0, then y must be 0.
Sorry. ये clear हो गया? I'll come to your question. Is everybody clear that we had yesterday we skipped this step? We had to show this, we showed this. Today I've shown you how to go from here to here. You had to carry the whole predicate with you, the hypotheses, to show if this is this, then this is this, this is this. Then when you reached here, now you prove this. Clear? एक बार पढ़ लो घर जाके फिर से. Doubt हो तो मुझसे पूछ लेना, है ना? You can ask me again. Yes, what were you saying? Tell me.
I was asking about some alternative.
Of course we can do alternate ways. Tell me.
Where I'm keeping A transpose x as y.
Right. So you want to show if we have to show this A transpose x is equal to 0, then x is equal to 0. Now you want to call this as y.
If Ay equal to 0, then y must be 0.
Ay is equal to 0, then y is equal to 0. This we can't say
Because it's
because the rows are linearly independent, not the columns of A. The columns of A, if you write them, they will be A1 to AN. It's an N R cross N matrix, no? This is Y1 to Yn. So A1, Y1, A2. If the columns were linearly independent, then I could have said this. But the columns of this are not linearly independent. The rows are linearly independent. R is less than N. Clear? Anybody else? Yeah, keep asking. In the lab, somebody asked me a question about LP transformation. You ask in the class. Because the others, he was thinking I'm making some matrix of matrix. I don't know what. Who asked the question? Is he there today? Actually, you asked. So you ask in the class, stop me. Don't be shy, because you are getting confused and there will be 5 others who are getting confused. I don't know how much what I'm teaching is too easy or too difficult for you. I'll come to know 2-3 weeks later that how is my pace going. So you have to give me feedback right away.
So there was one part left that A transpose A is not independent.
That you proved the same way. Now at least do that effort.
So we can pre-multiply with X transpose, so it became AX whole transpose times AX.
You can prove it the same way. The way we have done this, you can do it the same way. The other side was that, like he was saying, one side I said no, we'll not do because that's not invertible. So you can similarly prove that is, and try it. I would say, if you want to learn from the class, do that proof by yourself, so that you can ensure that you've understood what I'm trying to tell you. Okay? Okay. So what we'll do is now we'll finish the last problem. Then we'll come to Did anybody went through the solution or gave it a thought, the last problem? Nothing, you don't do anything at home. When I was undergraduate, I used to go and study in the afternoon. I don't know about the lecture. I used to always study. So that whatever is taught can be if you study the same day it is taught, it will be probably much easier to understand than if you study it 10 days later. You forget. So the last thing we were doing was example 2, and the example 2 stated that we want to go from a unconstrained problem to a constrained problem. And the question was, why would you want to do it? And the answer was to keep the smoothness of the functions going. So example 2 was, let V going from Rn to Rm and you define fx is equal to the infinite norm of this V, which is a vector function. I'm not writing the whole thing. Or this is max of Vi of x, I going from 1 through m, you had to minimize this. Okay, so problem is written for you, right? You the question was that this first we had to show that these are smooth. It's a smooth function. So let this be a smooth vector function, and then when we write this, I told you that this function f of x, which is the infinite norm of V, which means maximum of absolute value of components of V, that is not smooth. How did we prove that is not smooth? What is smooth function? See, infinity, all the derivatives are nice and continuous, like up to infinity, whatever the derivative exists. But we took an example that if your V1 and V2 are, for example, just straight lines, y is equal to x, y is equal to minus x, then your f function would be this. Because you're taking positive of this, although you're taking absolute value, so both of them will anyways flip to the other side. But nevertheless, it will become a V function. And when you take the derivative of this, it will turn out to this, which means that it is not even C1. Correct? Now the question was, convert, this is unconstrained. Everybody agrees? But I am saying now convert this to constrained problem and keep the smoothness with you. Keep the smoothness in the sense, keep the C infinity of the objective function and the constraints which you are going to create a nice optimization problem. So how do you think we should do it? Tell me. Think, did you go through the solution? This is uploaded in the slides. So, is it okay if we take a tutorial? Do you have any slot free on Monday, Tuesday?
Let me check.
It looks like this class will be 2:10 and 2:50 and there will be not enough time to do the tutorial. So we can either keep it at 5:30, but you will hate me for keeping 5:30 on a Friday. So if you have a free slot Monday, Tuesday, then we do it there. I don't want it to carry it to next week.
So on Monday we have classes from 9:30 to 10:30 in the morning slot. That's all.
Oh, acha, that's. So then can we do it 10:30 tutorial? है ना? Not stress you out because there are 5 questions. Already I could see people are getting confused, so we'll not do it in a hurry. है ना? So let's give this a time. So tell me now, what should we do?
So we can create m square equations. We can say that vi of we can make an m square conditions, and each condition will be like vi of x should be greater than should be less than equal to vj of x, and suppose something is maximum, so that should like satisfy all of these conditions. So the intersection of all of these m square conditions will be
How
that
are
point.
you getting m square? What's your name? I forgot.
I'm Abhinav.
Abhinav. Okay, yeah.
Like for every
But
I.
you are on the right track. Can you work it out? Try to work it out. Anybody else besides Abhinav, what should we do? Everybody is clear what the goal is? Goal is transform this into a constraint problem and keep the smoothness, which means keep the nice objective function, and whatever new constraints you create, they should also remain smooth or C infinite. Right? So let me give you a hint. Okay. So let you create a new variable. T is equal to max of Vi of x. I going from 1 through m. Let's say I create a new, instead of calling this as f of x, I am calling this another variable t, and I'll create my extended search space or the variables as t and x both. So what is my objective function now? What I am trying to minimize? T. Everybody agrees, because I am trying to minimize f of x. I've just not to keep x with us and create a new variable. I'm calling f of x as another variable t. That's the only thing I'm doing. So I'm saying minimize t with respect to x hat. That's a different story, that t is a function of x and that's embedded in there. But for us, from a bigger picture, I'm not worried about it. So now if you see the smoothness of this is infinitely smooth, because it's just a linear function of t, if t is a variable. So you got one part done, that you transformed this into a smooth objective function. But what about this guy now? So now let's try to look at this guy. So what does this mean? Absolute value Vix. So Vi of x. What should we write and expand it? Tell me. Think that much with me. Good. Who answered it? Who answered? What's your name? Huh?
Aviral.
Aviral. Okay. Yeah, Aviral. And I going from 1 to m. That was already there. I just retransformed it. There's any difference between them? No difference, because I'm saying maximum of that absolute value is t. So t is the upper bound of Vi of x absolute. And it's true for all I going from 1 to m. Everybody with me? But is this good? Is this infinitely differentiable? Or do I need to do anything beyond it?
Minus t and plus t and
Correct. There is an absolute function which is a bad function. You know that absolute values take the mirror image across the x-axis. They convert everything negative to positive, which means that they will create some kind of a joint and it will be not continuous or differentiable as you keep taking the higher derivatives. So this is probably not the way. So as Atharv said, we'll try to expand this. So what does absolute function mean? It means minus t is less than equal to Vi of x is less than equal to t. Correct? Now we want to write it in the standard form. So we'll take this guy separate and this guy separate. Everybody clear? I just expanded the absolute function. Okay. So I'll write this guy separate and these guys separately, and with a greater than equal to 0 sign. So I will write this as Vi of x plus t greater than equal to 0, and then I'll also write t minus Vi of x greater than equal to 0, I going from 1 through m, or t plus Vi of x greater than equal to 0. Now if I have to expand this, then I'll write t plus v1 of x greater than equal to 0 all the way till t plus vm of x greater than equal to 0, and parallelly I would have t minus v1 of x greater than equal to 0 and t minus vm of x greater than equal to 0. So these are all my constraints. and this is my objective function. So now let's look at the constraint. Is this C infinity? Is this smooth? Yes, it's a linear function of t because x hat is just t and x. So this is smooth. Is this smooth? Why? Because it's given to be a smooth function, right? So every component of v, v1 to vm is smooth. Is a addition of smooth function smooth? Yes, that property carries over. So this is smooth, all are smooth, this is also smooth, all are smooth. So this is smooth and this is smooth. So you converted a bad problem, unconstrained, which was not even C1, into a constrained problem which is C infinity. Everybody with me? Yes, happy? Yesterday's joke were left, will we crack a joke? Where's my phone? So what we'll do is we'll do one more problem. We'll start the tutorial, you finish. Usually I don't come on tutorials. I let the TAs do it. Today I came because these two things were carrying over. I thought by the time Wednesday come, you will be a blank slate and you'll not remember a thing. So it's better that I get this reinforced today. But I would strongly suggest please go through the notes when you go home. I'm trying to make it as easy as possible. But then things will come really fast after this. So then if you don't understand these two lectures, it will be difficult to carry forward. ठीक है, तो अभी let's do. I'll free you at 2:15 so that you can go on time. But we'll do one more problem and then we'll stop. And the remaining 4 problems of the tutorial you do it on Monday 10:30. ठीक है?
Yes, sir.
Okay. Do you have the tutorial open somewhere? So you printed it. So we'll try to clear your Abhinav's doubt, which I realize that many of you are getting confused about. So we'll make you work on this. You take a harder problem or an easier one. Okay, let's not. Well, if I start this LP problem, then it will be probably difficult. Let's do the last problem from the tutorial. This one would be interesting. Now I'm calling this in the continuation of the notes example 3. So it says solve x1 plus x2 or minimize x1 plus x2 subject to x1 square plus x2 square is equal to 1 by eliminating x2. Show that choice of sign of square root during elimination leads to wrong answer. Can you show me? Do it yourself. This is not too hard actually. So again we are on the same track, converting a constraint problem to a unconstrained problem, because if you eliminate x2, this constraint will go away. So now you have to solve for this and tell that if in this elimination process, if you use a wrong sign of the square root, you'll get both plus or minus, then you will end up with the wrong answer. Show me. Can you try it? That's why I said if you don't want to write my note, that's okay. But bring a notebook to scribble. Or if you want to scribble on your iPad, then do it. But show me, think with me. You have a lookalike in the second year. I don't know what his name is. He looks just like you. I taught second year math of AIML, so I just But why is he sitting in my class? Then it's different. Show me, huh? Yeah. That's what. Sorry, which negative sign? You try both. No? That's what it's saying. It's saying if you don't choose the right sign, then you'll end up with the wrong answer. That's what you have to show. So try both. Make a tree. First do it with the plus, then do it with the minus. Were the 2 lectures yesterday too much for you? Yes. Okay. Okay. Here. You're getting it or you're getting lost? I know you two are getting it. Because you respond. You? So solution says if I put x2 is equal to plus or minus square root of 1 minus x1 square. So I'll do the case 1 when x2 is positive 1 minus x1 square, and I'll do case 2 when x2 is equal to minus of square root 1 minus x1 square. Has anybody done it? What will you do after that once it becomes a unconstrained problem? Minimize x1 plus square root of 1 minus x1 square. So this is now your optimized. What will you do to find the minima? Find the gradient. Well, in this case just the f prime, df over dx. Make it equal to 0. You will get candidates for minimizer. To show that it is a minimizer, what do you have to do? The double derivative, f double prime, right? Or in the n-dimensional case, make the gradient equal to 0 and find the Hessian. Although there is a function of one variable, so you're just doing f prime and f double prime. Correct? So once I take this guy as f of x1, I make f prime of x1 equal to 0, then what do I get? I get x1 is equal to plus or minus 1 over square root 2. Is that okay? And x2 would be 1 over square root of 2. So minus 1 over square root of 2, 1 over square root of 2 will give you the minimum value as square root 2, and when you take minus 1 over square root 2 and 1 over square root 2, you will get the minimum value as 0. Is everybody doing this only? I have not done f double derivative, but you should do that, है ना? F double derivative, you should check that it is greater than equal to, strictly greater than 0. Okay, so if I do this case 2, what do I get? Can you do it and tell me? Attendance pass kari kya? हाँ, one page is coming on one page. So keep filling your attendance. I don't look at attendance unless there will be a curving between AA and AB. That's the only reason I take when I have to decide, because I can't give more than 15% AAs. So that's, otherwise there is marks for attendance. So if you feel you don't need a AA, so technically attendance is not important. But I would love that you come to my class and learn and do joyful learning. Okay. What do we get in this case? So once I differentiate this guy, so now my function becomes minimize x1 minus square root 1 minus x1 square, and then you make f prime of x equal to 0, then you get x1 is equal to again plus or minus square root 2, and then you get x2 is equal to minus 1 over square root 2. When you take 1 over square root 2 and minus 1 over square root 2, the function value turns to be 0. And when you take minus 1 over square root 2 and minus 1 over square root 2, the value turns out to be minus square root 2. So what happened? Which is the minima function value? So these are not your minimas, neither is this your minima. So the idea was to tell you that the choice of the sign may lead you to a wrong result. है ना? Do this f double prime also, है ना? ठीक है? So we'll stop here. There are 4 questions which you may finish in 40-45 minutes on Monday also. Shouldn't take too long. Well, the first 2 problems are slightly longer. Your doubt got cleared, right? That you asked in the lab. So anyways, so he'll emphasize those things. So we'll do transformations of LP where you have some problem how to convert it to a standard form. So first 2 problems are slightly harder, the other 2 are easier. Anyways, the tutorial is on the drive if you want to take a look before that. Okay, thank you. हाँ हाँ please.